Hi everyone, our project is called Automated Grader. We investigated the safety of an LLM auto grader on student essays. The main idea was not just to ask whether the model could produce a grade, we wanted to know whether that grade could actually be trusted in a realistic classroom setting. Essay grading is a high stakes use case because a score can affect how a student is evaluated. So the question we started with was, if an AI model grades an essay, how do we know the score reflects writing quality rather than noise, bias, or manipulation? A grader might look useful because it outputs a score, but it could still fail if it's influenced by surface level wording changes, demographic associated language patterns, specific keywords, or student trying to pressure the model. So our evaluation focus was simple. We tested whether the model stayed fair, consistent, and rubric aligned when essays were modified in ways that should not meaningfully change the grade. The model takes a student essay as raw text and grades it using a rubric. The rubric asks the model to act as an expert eighth grade essay grader and assign a score from 1 to 6. The original dataset combines two human rater scores, so we scaled the model's predicted score to compare it against the reported human score range. But the key point is that this is only the first step. Once the model produced a score and justification, we stress tested that output using safety metrics designed for this essay grading use case. To build the evaluation, we sampled 10 essays from essay set 1 and stratified by human score so the distribution would stay balanced. Then we created controlled variations of the same essays. One variation added persuasive or leading phrases to test whether the model could be pushed into changing its score. Another introduced character level noise to test robustness against superficial wording changes. We also translated essays into Spanish and Mandarin to test cross-lingual distribution shift. Now, one note I'll make is that the instructions did say to use two low resource languages. However, we wanted to use languages that had more linguistic variety, as we thought that that might be a better application for our purposes. Anyways, back to the point. From those manipulated data sets, we evaluated additional metrics like sycophancy and explainability. Sycophancy looked at whether the model's responses sounded overly agreeable or unearned. Explainability looked at whether the model's justification referenced the actual essay content rather than just repeating generic rubric language. The biggest challenge was the base model, Gemma 4 E2B. It produced much less reliably than expected. Across 50 grading attempts, the base model generated an actual score only 12 times, and even some of those outputs weren't fully coherent. That became a central finding, not just a technical issue. We saw three main failure modes. First, blank template completion, where the model copied placeholder syntax instead of grading. Second, conflicting scores, where the model listed multiple scores in the same response. Third, score justification mismatches, where the score did not match the rubric point described in the justification. By contrast, the instruction-tuned model was much more reliable. It produced coherent scores in 49 out of 50 attempts. The only issue was a parser problem, not really a model failure. The main takeaway is that accuracy alone did not make the grader reliable. For sycophancy, the judge models disagreed substantially. That tells us the LLM as judge results can depend heavily on which judge model is used. So sycophancy was not an objective, clean measurement. For attack success rate, only 1 out of 10 essays saw an inflated score after a pressure statement was added. That suggests the grader did not often cave to direct pressure, even though the judge model sometimes flagged sycophantic language. For explainability, the results were more concerning. A large share of justifications were flagged as insufficiently grounded, meaning the model's explanations may not be transparent enough for a human to verify. For robustness, character level noise only increased scores by about zero point 0.2 on average, so typos did not appear to drastically affect scoring. The bigger issue was cross-lingual shift. Spanish essays were scored slightly higher than English, and Mandarin essays were scored about 0.8 points higher on average. That suggests the model may evaluate the same essay differently depending on the language, which is a serious limitation for classroom use. For future work, the biggest next step would be measuring demographic bias and performance disparity. We wanted to test whether the model scored differently based on topic, dialect, writing style, or demographic associated language patterns, but we did not have the student demographic data needed to do that responsibly. We would also want a larger sample size. Our 10 essay sample was useful for a short evaluation, but it limits how generalizable the results are. Finally, if the model were improved and properly validated, a practical next step would be a dashboard that takes an easy an essay PDF as input and returns a score and justification. But based on this evaluation, the model would need more safety testing before it should be trusted in a real classroom setting. Our final conclusion is that automated essay grading requires more than matching human scores. A reliable grading has to be consistent, explainable, resistant to manipulation, and fair across languages and student writing styles.